Hello, this is my contribution to Olly's Workshop's 2023 Advent Calendar series. Be sure to pay him a visit and see what else he's been up to. From time to time I need to cut sealing washers and discs, and for this task I have a nice Wad Punch set. Now I've no affiliation whatsoever with Morn Industries, but I think they're worth a mention as British tool companies are few and far between these days. This set of cutters is way ahead of the cheap eBay specials I had previously. It's pretty simple to use. You just screw your selected cutter onto the handle, pick a spot on your material and bash the end with a hammer. Only lack of practice means quite often I don't hit it quite square, so the disc isn't cut all the way through. Or I overcompensate and hit it so hard it practically goes through the tabletop. Sometimes I use the cutter on the vise as it's nice and controllable, but holding everything in place and winding the handle without crushing my fingers can be a bit tricky. Plus, the larger cutters overhang the jaws, which adds another layer to juggle with. And doing it this way loses the benefit of the spring-loaded centre pin, which helps with alignment when making washers. I have an Arbor press too, but that's only slightly less fiddly than using the vise. The idea was somehow to attach this bit to this bit and see if I could make it work any better. My plan was to remake the handle, only shorter, and add the means to attach it to the ram. The attachment box will be made from some pieces of EN3 steel strip. It's been well over a year since I last used a TIG welder, and when I realised I had some gas left, today seemed like a good day to fire it up again. I didn't want to risk damaging the Arbor press, so I found a piece of scrap tube and slimmed it down to be just a little larger than the ram. Given my general inability to weld, and the part not needing to take any real weight, I went for a few light blobs rather than attempting fillets. And before anyone comments, I know this is horrible, but for this job it's adequate. I enjoyed doing it, and I'll be just a tiny bit better next time. I deliberately made it a loose fit, so the cutter stands a chance of self-aligning as it makes contact with the material I'm punching a hole in. After squaring up the ends, I moved on to the cutter holder. All the sizes are pretty arbitrary, apart from the threaded bit on the end. The short length made it a bit tricky to measure. It could be 1.75mm pitch, or it could be 14 TPI. For no better reason than it'll be easy to set up, I'm going with 1.75mm pitch. Given what it is, so long as the end doesn't fall off, I don't think it's that critical. The most difficult feature would be cutting the thread, so I'd start there to save me remachining the rest if it went wrong. I chucked a nub of steel and reduced the end. Once to size, I cut a relief down to the thread's minor diameter to give me a runoff. With the big shoulder on the left, I figured it might be safest to cut the thread away from the chuck. Now this has caught me out before. Just reversing the tool travel isn't the answer. If the lead screw and chuck are turning the same way, I get a right-handed thread. If they're turning in opposite directions, I get a left-handed thread. So I'd need both to be turning the same direction, but with the tool travelling from left to right, which means reversing the whole thing, not just the lead screw. With only a short distance to get up to speed before the tool engages, very light cuts were the order of the day. It took a while, but I got there eventually. You may have noticed I made a few too many threads. This was my insurance policy against forgetting to wind the cut off before reversing the lathe, as the backlash in the lead screw would result in a full depth cut where I didn't want one. Next, I drilled and reamed an 8mm hole to take the centre pin. This is much larger than the original, and I'll explain the reason for that later. After cleaning up the outside diameter and trimming off those insurance threads, I flipped the part over to work on the other side. I parted a lump off the end to reduce the overall length and then took the diameter down so that the mounting box would be an easy fit. Next, I drilled out the centre hole ready to tap M10 by 0.75. The enlargement for the threaded section left a step in the bore near the end, which will stop the plunger from falling out. A slight shortcoming of the original handle is that the plunger can leave a dimple or even a hole in the thing you're cutting. It's not always a problem, but sometimes I want a perfect disc. To solve this, on my new version, the pointy bit will be optional. Once I'd found a likely looking spring, I was able to figure out the relative lengths of the plunger and bore. The plunger part would be made from silver steel, the outer carrier from 8mm, and the removable inner from 4mm. After grinding a dull point on the end, I drilled a hole to take a 2.9 by 4mm neodymium magnet, which would prevent the pin from just falling out. The 8mm carrier got a hole to take the removable pin. I made a second pass to make it flat bottomed, so the little magnet would have something to stick to. On the other end, I reduced the section to 3mm so that I could die thread it. Then I made a brass nut to screw onto the plunger. This becomes the shoulder which stops the plunger from falling out and gives somewhere for the spring to locate. The final part to make was a threaded plug to keep the spring in place. I chucked a piece of 10mm brass rod, drilled a pilot hole in the end and then followed it with a hex brooch. I die threaded an M10 by 0.75 thread on the outside, created a reduced section to hold the spring and then parted off. Once I drilled and tapped a couple of holes, all that remained was to put it together and give it a test. That's it for this one. Don't forget to head over to Olly's workshop to see what else is on the menu. Thanks for watching. I hope to see you next time.